Back at AP Review, this is 2015 ABBC Free Response 1. It is a calculator problem. So we were given two functions, R of t and D of t. I already put them in my calculator as y1 and y2, which is why I made that note. The rate at which rainwater flows into a drain pipe, timeout, this is a rate in, rate out problem. Where one of these is going to be the rate the water's coming into the drain, one's going to be the rate it's coming out. And these are pretty common problems on the AP, whether it's water coming in and out of a drain, people getting in and out of a line, bananas going on and off a fruit stand, right? So R of t is the rate the water is coming in. That's why I wrote rate in right here, in cubic feet per hour. From t is 0 to 8. The pipe is partially blocked, so d of t is how fast the water is draining out, so rate out. Again from 0 to 8, and there are 30 cubic feet of water at time 0 in the pipe. So part A. How many cubic feet of rainwater flow into the pipe in that 8-hour window? So into is only talking about R of t, right? So what into is asking is if this is the rate you flow in, then the amount that has flowed in is about integration, right? So we're going to integrate R of t dt from 0 to 8. And that's all the AP needs to see. You're using their own notation, right? And then you're going to quit out of that. Sorry, I was originally in here, right? I put both of those in as my y1 and y2. I quit out. I'm going to do math 9, right? So to do this, I'm going to do function integrate, which is math 9, y1, which is what I called my R of t, with respect to x, because x is my independent variable here, from 0 to 8, right? So I do math 9, right? I'm going to go to vars, over to function, pick y1, comma, with respect to x, from 0 to 8. Let me double check that. There you go. I'm going to hit enter, and my calculator will do it for me and give me the 76.570. Now, you actually don't have to write cubic feet here because the question said how many cubic feet, so the units are implied. But it doesn't hurt to know the correct units. Part B is the amount of rainwater in the pipe increasing or decreasing at t equals 3. Okay, so the thing to keep in mind in all of these rate in, rate out problems is that the rate of change of pretty much anything, right? So of the amount of water, but it doesn't have to be the amount of water. It could be the amount of people in a line. It could be the amount of bananas on a banana stand, is really just the rate in minus the rate out, forever and always. So it's going to be R of t minus D of t, right? So what I'm going to do, knowing I'm going to need this function more than once, I'm going to need the total rate of change of the water, I'm going to go back to my y equals, and I'm going to actually make y3. I'm going to call this guy y3. Right? I'm going to make my y3 vars over to function y1 minus vars over to function y2. So I did y1 minus y2. That means that my y3 is going to let me find out essentially the rate of change of the water. So what I want is I want to know the value of R of 3 minus D of 3. If it's positive, then the rate of change of the amount of water is positive, which would mean the amount is increasing. If this result is negative, then it means the rate of change of the amount of water is negative, which would mean that the amount is decreasing. So I go ahead and put that in as my y3, and I'm going to go ahead and quit out. So then if I hit graph, right, I turned off my y1 and y2. The only thing I'm graphing right now is y3. So if I hit graph and I hit trace, right, so I hit graph, I'm going to hit trace, and I'm going to hit 3 because that's the time I want, and I'm going to get that this is a negative 0.313 or 4, which is less than 0. So since R of 3 minus D of 3 is less than 0, the amount in the tank is decreasing at t equals 3. That's my part B. Part C. At what time in the window from 0 to 8 is the amount of water in the pipe at a minimum justify your answer? So the thing is that extrema can only happen where the rate of change of the water is equal to 0, right? So my extrema are going to happen when R of t minus D of t equals 0, because this is the rate of change, right? This is the rate of change of the amount of water, rate in minus rate out. So really, it's going to happen when R of t equals D of t, right? So there are a couple possible candidates, or it's going to happen in an endpoint, because those are the only possibilities, which would be t is 0 or 8. So basically, if I find the times when R of t equals D of t, and I find, and I put them on a table along with t is 0 and t is 8, I can calculate the value of the amount of water in the tank at those times and tell you which one's the minimum. Sorry, had to stop for a sec. Back with part C of 2015 ABBC free response 1. So for part C, we were tasked with finding at what time in the window from 0 to 8 inclusive is the amount of water in the water pipe a minimum. Justify your answer. When last we left off, I was explaining that the only possible extrema happen at the critical points for the amount of water, which would be when the rate of change of the amount of water, R of t minus d of t, equals 0. So essentially, or at the endpoints t equals 0 and t equals 8. So we need to find when my y1, right? So I'm going to second calc intersect and find when my y1 equals my y2, and I'm going to get a time, right? And whatever times I get here, in addition to 0 and 8, I'm going to find the amount of water in the tank, and then I'll be able to ascertain which one's the minimum. So last time, I had changed my y3 to be y2 minus y1. One interesting option is you can either do second calc intersect with y1 equal to y2, or since you already have y1 minus y2, I could do second calc 0. So if I want, I can go ahead and graph, right? If I graph this, you'll see that on my window from 0 to 8, this 0 is past 8, right? So I can second calc 0. So second calc 0. I'm going to make sure that this first one does not fall in the window from 0 to 8, just in case. I'm pretty sure it does not. Yeah, it's at 0. So at time 0, the rates are the same. So that's 1. So at 0, but we already knew time 0. So if I second calc 0 for the other one, I'm going to go to the left of that first 0. Again, if I had used my y1 and y2, I could have done second calc intersect, but because my y3 was already this, I just did second calc 0. And I'm going to get a time that is t is approximately 3.2716584, which I'm going to store as A in my calculator. So I'm going to call that A, right? I'm going to call that A because I'm going to have to use it again. So the way I do that is I quit out, and it was the X value of that 0, and then I hit stow, which is right above the on button, and then alpha A, right? And so now when I use A, that's the value I get. So what that means is that there are a handful of candidates for the extrema here. So I want to know which one of these, 0, 8, or 3.27, blah, 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 is the minimum value of the water in the tank. So let's go ahead and write what we know. So if we erase this for a sec. So here are my candidates. So these are my critical numbers, right? 0, right? And the amount in the tank at 0 is 30 cubic feet, because they told me that. 3.271 or 2, depending on if you're at a truncate, and 8. Those were the 3 possibilities, right? Now to find these values, right? To find this one, right? To find the 3.271, right? I want the amount in the tank. So to find this amount, it's going to be the amount at the start plus the amount I gained minus the amount I lost, right? So if we want to write that out, what that's going to look like is it's going to be the starting amount plus the integral from 0 to 8 of the amount I gained, which is R of t, minus the amount. So I can actually do these together, minus the amount I lost, which is my dt, right? Oh, sorry, and it wouldn't be 8. It would be from 0 to A, which is that 3.271 blah, 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 which I called A, right? If I want to find the amount at 8, I'm going to use the same formula, 30 plus, but this one will be the integral from 0 to 8 of R of t minus d of t dt, right? Because this is the amount I gained over that window, and this is the amount I lost in that window. So I'm going to go ahead and find those two numbers, right? And so when I do that, I can actually be pretty lazy about it. I can type this once and then just change the A to an 8. So conveniently, I called this my y3, right? So what I'm going to do for both of these is I'm going to do 30 plus function integrate, the thing I called y3, because that was my R of t minus d of t, with respect to x, from 0 to, and then whichever of the two things I need in this particular problem. So I'm going to do A for the first one. So I'm going to do math 9. Oh, sorry, I'll do my 30 first. 30 plus, right? Math 9, right? I'm going to go to vars. I want to go over to function, and I want y3 with respect to x from 0 to alpha a. Oh, I missed my comma alpha a. Cool. All right, so that should be my first one, right? And I'm going to hit enter, and hopefully I get something in the neighborhood of a 27.96. Hey, I did. Okay, so this is a 27.964 or 5, right, depending if you're on a truncate. And then I need to find the value at 8, and in order to do that, right, I'm going to go ahead and do second enter and just change that A to an 8. and I get 48.5 whatever, whatever. So 48.543 or 4, right? And so my answer for when, so the minimum amount is the 27.964. And their question was, at what time is the minimum amount? So at t equals, we'll do approximately 3.271 or 2, and that is in hours, right? The minimum, so that's the minimum, right? So, and they ask me to give justification. My justification is that I used the only possible critical points. I found the value at all those critical points, and that value is clearly the lowest, right? Cool. Part D. The pipe can hold 50 cubic feet of water before overflowing. For T values greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe overflows. Write but do not solve an equation involving one or more integrals to give the time W when the pipe will overflow. Okay, so it's going to tie into this integral that we already have, except instead of 0 to 8, right, we're going to be talking about 0 to some mystery time, okay? So part D, right, for part D, we want 50, right, this is the overflow amount, right, that's the overflow limit, to be the starting value, right, which was the 30, plus the amount gained minus the amount lost, right? So that's going to be the integral from 0 to some mystery W, right, because they said that the time would be W, of R of t minus D of t dt, right? So this is the amount gained or lost in between 0 and W, right? This is the starting amount that was already in the tank, and this is the amount to hit overflow. And that's it. That's what they want.